formula for calculating the ampacity of a round bus bar is ampacity equals the area of conductor in circular mils multiplied by the allowable current density. The formula for calculating the area of the conductor for a round bus bar is area equals pi multiplied by diameter divided by 2 squared. Here are the steps to calculate the ampacity of a 1.5 inch round aluminum bus bar. Firstly, convert inches to circular mils. 1 mil equals 1 divided by 1000 inch. Diameter equals 1.5 inches, which equals 1.5 multiplied by 1000 mils, which equals 1500 mils. Secondly, calculate the area of the conductor. Area equals pi multiplied by 1500 divided by 2 squared, which is approximately 1,767,150 circular mils. Thirdly, use the allowable current density for aluminum bus bars, which is 700 amps per square inch. Fourthly, calculate the ampacity. Ampacity equals 1,767,150 circular mils multiplied by 700 amps per square inch. Ampacity is approximately 1237 amps. Now let's talk about copper bus bars. The formula for calculating the ampacity of a copper bus bar is the same as for aluminum. However, the allowable current density for copper is higher, typically around 1000 amps per square inch. These calculations are approximate and should not be used for actual electrical installations. Always consult with a qualified electrician and refer to the National Electrical Code for specific requirements. To elaborate, let's delve deeper into the concepts and calculations involved in determining the ampacity of bus bars, focusing on both aluminum and copper. We'll break down each step and provide additional context for a comprehensive understanding. Firstly, let's revisit the formula for ampacity. Ampacity equals area of conductor in circular mils multiplied by allowable current density. This formula is fundamental to determining how much current a bus bar can safely carry. The area of conductor, measured in circular mils, represents the cross-sectional area available for current flow. The allowable current density is the amount of current that can flow through a given area of the conductor without causing excessive heat or damage. This value is material dependent, as different materials have different thermal and electrical properties. Now let's focus on determining the area of the conductor, particularly for a round bus bar. The formula is area equals pi multiplied by diameter divided by 2 squared. This formula calculates the cross-sectional area of a circle, which is the shape of a round bus bar. The diameter is the distance across the circle through its center, and dividing it by 2 gives the radius. Squaring the radius and multiplying by pi yields the area. To ensure consistency in calculations, it's common to convert the diameter from inches to circular mils. 1 mil equals 1 divided by 1000 inch. Therefore, to convert inches to mils, multiply the value in inches by 1000. For example, a diameter of 1.5 inches equals 1.5 multiplied by 1000 mils, resulting in 1500 mils. Now let's look at the example of calculating the ampacity of a 1.5 inch round aluminum bus bar. Firstly, convert the diameter from inches to circular mils. As previously calculated, a diameter of 1.5 inches equals 1500 mils. Secondly, calculate the area of the conductor. Using the formula area equals pi multiplied by 1500 divided by 2 squared, we find that the area is approximately 1,767,150 circular mils. Thirdly, determine the allowable current density for aluminum bus bars. A common value is 700 amps per square inch, but this can vary depending on the specific application and environmental conditions. It's crucial to consult relevant standards and guidelines to determine the appropriate current density for the situation. Fourthly, calculate the ampacity by multiplying the area of the conductor by the allowable current density. Ampacity equals 1,767,150 circular mils multiplied by 700 amps per square inch, which equals approximately 1237 amps. Now let's shift our attention to copper bus bars. The formula for calculating the ampacity of a copper bus bar is the same as for aluminum. Ampacity equals area of conductor in circular mils multiplied by allowable current density. However, the key difference lies in the allowable current density. Copper has a higher electrical conductivity and thermal capacity than aluminum, allowing it to carry more current for a given area. The allowable current density for copper is typically around 1000 amps per square inch, but this can vary depending on the specific application and environmental conditions. Again, it's essential to consult relevant standards and guidelines to determine the appropriate current density. It's important to emphasize that these calculations are approximate and should not be used for actual electrical installations. Real-world installations involve numerous factors that can affect ampacity, such as ambient temperature, grouping of conductors, and ventilation. These factors must be considered to ensure the safe and reliable operation of the electrical system. Always consult with a qualified electrician and refer to the National Electrical Code for specific requirements. The NEC provides detailed guidelines for conductor ampacity, rating factors, and other considerations to ensure compliance with safety standards. It's also crucial to understand the limitations of these calculations. They provide a theoretical estimate of the ampacity based on certain assumptions. In practice, the actual ampacity of a bus bar may be lower due to factors such as manufacturing tolerances, surface finish, and connection methods. Therefore, it's essential to perform thorough testing and verification to ensure that the bus bar can safely carry the intended current. Furthermore, the choice between aluminum and copper bus bars depends on several factors, including cost, weight, and performance requirements. Aluminum is generally less expensive and lighter than copper, making it suitable for applications where weight and cost are critical considerations. Copper, on the other hand, has higher conductivity and corrosion resistance, making it preferable for high-performance applications or harsh environments. In summary, calculating the ampacity of bus bars involves understanding the formulas for area and ampacity, converting units appropriately, and using the correct current density values for the material. However, it's crucial to remember that these calculations are approximate and should be verified by qualified professionals and relevant standards. Understanding the properties of both aluminum and copper is essential for selecting the appropriate material for a given application. In addition, other factors affect the selection too. Firstly, consider the operating temperature. High operating temperatures can significantly reduce the ampacity of bus bars. Secondly, evaluate the environmental conditions. Corrosive environments can degrade the bus bar material and reduce its ampacity. Thirdly, consider the mechanical stresses. Bus bars may be subjected to mechanical stresses due to vibration, thermal expansion, or short-circuit forces. Fourthly, check the connection methods. The way bus bars are connected could affect their ampacity and reliability. Fifthly, consider the maintenance requirements. Regular inspection and maintenance are necessary to ensure the long-term performance of bus bars. Sixthly, think about the future expansion. It's important to consider future expansion when selecting bus bars to avoid costly upgrades later. Seventhly, check the code compliance. All electrical installations must comply with relevant codes and standards. Eighthly, assess the safety considerations. Safety is paramount when working with electrical systems. Remember that working with electricity can be dangerous, and it's essential to take appropriate precautions to avoid electrical shock or other hazards. Always energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment such as gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization of the circuit. Work in a well-ventilated area to avoid exposure to hazardous fumes. Be aware of the potential for arc flash and take steps to mitigate the risk. Never work alone and have someone nearby who can assist in case of an emergency. If you're not comfortable working with electricity, consult a qualified electrician. In conclusion, calculating bus bar ampacity is a critical aspect of electrical system design. By understanding the formulas, factors, and safety considerations involved, you can ensure the safe and reliable operation of your electrical system. Always consult with qualified professionals and adhere to relevant codes and standards. This will help prevent accidents and ensure the long-term performance of your electrical equipment. Also remember that the ampacity of a bus bar is not a fixed value. It can change over time due to factors such as corrosion, contamination, and mechanical damage. Therefore, it's important to periodically inspect bus bars and perform maintenance as needed to ensure their continued safe operation. Use appropriate cleaning methods to remove dirt, dust, and other contaminants. Repair or replace damaged bus bars to prevent electrical hazards. Tighten loose connections to ensure proper current flow. Apply corrosion inhibitors to protect bus bars from corrosion. Keep bus bars dry and well ventilated to prevent moisture buildup. By following these maintenance practices, you can extend the lifespan of your bus bars and ensure the continued safety of your electrical system. Bus bar systems are crucial components in electrical distribution networks. They serve as centralized points for distributing electrical power from incoming sources to multiple outgoing circuits. Bus bars are typically made of copper or aluminum due to their excellent electrical conductivity. They come in various shapes and sizes to accommodate different current carrying capacities. Bus bar systems are used in a wide range of applications, including power plants, substations, industrial facilities, and commercial buildings. They provide a reliable and efficient means of distributing electrical power to various loads. Proper design, installation, and maintenance of bus bar systems are essential for ensuring the safe and reliable operation of electrical networks.